Recording. Welcome to the latest WIPAC webinar brought to you by the Water Industry Process Automation and Control Group. This month's webinar even is on flow-to-full treatment in more general. It's something that's a very active and difficult deliverable in the next asset management period within the English and Welsh water industry coming forward, and there's a lot of investment going on in this area. So what I'm going to speak to you today is flow management in more general. I will probably pause my video just so it doesn't protect the bandwidth. For those of you who don't know me, I am Oliver Grievson. I'm the Executive Director of Water Industry Process Automation and Control. It's a LinkedIn group that I set up back in 2011. Will have been going 9 years this year. And it's all about knowledge sharing of instrumentation, automation and control, the smart water industry. My day job is with ZTech Control Systems as technical lead for the water industry. So I do flow as part of my day job. We're lucky that this platform today is supported by Wastewater Education, which is an American wastewater education charity, of which I am the chairman. And as it's a charity, we can get the Adobe platform, which this is on, a little bit cheaper. So today's webinar is on flow management, measurement and control. What I'm going to be talking about today is basically this. I'm going to go through flow, what it means to the water industry, some of the technical definitions. As is my normal want, I will get a bit controversial and talk about how we've regulated flow over the past few decades and some of the challenges that the industry has faced. I will touch on how we measure and control flow, but I'm not going to touch on that in a huge amount of detail because otherwise I'll be here for hours. And a lot of you on the webinar today already know about how we measure flow, already know a lot about that. But then I'll also touch on the asset management period starting in April and probably go even into the following asset management period and some of the challenges that we face with wastewater flow measurement and management. How, yes, we're going to have to compromise, how things aren't necessarily ideal, and then we'll have a bit of a Q&A session towards the end of the webinar. You have a chat window down the bottom. I will be monitoring it as we go through and either ask questions as we go through or we'll move back to the other screen towards the end and we can have a bit of a discussion at the end. So, the techie bit. Wastewater flow has always been a bit of a poor cousin to the management of quality. I remember from being in the water industry for a very long time now, and compliance has always been king, meaning quality compliance. We've always worried about BOD, ammonia, solids, the non-sanitaries, the sanitaries, the non-sanitaries. Flow has been there, but it's not really had the focus that it deserves. It's never affected the OPA points, which is something that's going to change. Quickly going through the PR19 final determinations, you can look at in the future flow and flow management, flow compliance is going to affect OPA points, is going to affect the industry quite severely. When you look at it, even 1% change in wastewater compliance below the 99% dead band across nationally is about £21 million in in ODI penalties. So it's not huge in the grand scheme of things, but has a huge potential to impact the way the industry works. And with the programme in the next asset management period, there is going to be a cultural change. We are not going to, from an operational point of view, be able to use storm tanks for operations management other than the method of speaking to the agency and working with the agency. But it's going to take a bit of a change to the way we work. To go to the very basics, because of course I don't know who's on the call. Some people may or may not know it. Some of the people who are joining us from America, they deal in a slightly different terminology. We can split it into Formula A, flow-to-full treatment, and dry weather flow. Formula A, often been described as 6 times dry weather flow. It is a bit of a misnomer. It's what sewers have been typically designed around. It's been a theoretical thing in the past. And when you look at the equation, 1360p plus 2e plus dry weather flow. Now, I remember when I was an engineer, E was always something that we basically looked at. We looked at what the trade permits were, and we took what the industrial customers were consented to, not the way they're actually performing. DWF, I'll come on to a bit later, but when you go into the history of DWF, again, it's not the easiest thing to understand, which you can understand why people have said, oh, Formula A, 6 times dry weather flow. A lot of the smaller wastewater treatment works out there, a lot of the treat all flows works are designed to 6 dry weather flow. Rightly or wrongly, it is a bit of an argument. So DWF, if you go back to 1975, the Glossary of Wastewater Pollution Control, which is the Institute of Wastewater and Pollution Control, turned into CIWEM. It was one of the organisations that turned into CIWEM. You can literally go back, and I've got a copy, I dug it off the internet, and the glossary says the average daily flow to the treatment works during 7 consecutive days without rain, excluding a period which includes public holidays, following 7 days during which the rainfall did not exceed 0.25 millimetres. So you can understand in the past why people really struggled with the dry weather flow concept. If it was, you weren't allowed public holidays, you had to have 7 consecutive days, 7 days without rainfall, 7 days without this, without that. How did you actually define dry weather flow? And that's back from the 1970s. A lot of people, and some people on the call may well have been aware of the work that UK Weir did via what's now Servolet Technology, part of Servolet Technologies, on the 20th percentile value. And this was a big change in the water industry. The 20th percentile, the Q80, Q90 figures, it was a big change because probably when that study first came about, we were actually able to define an actual number for dry weather flow and take it from there. A lot of people for dry weather flow, and I've just noticed my formula's wrong on this. Dry weather flow, of course, is PG plus I plus E. Now, E, as I said with Formula A, what precisely is it? Is it the consented value of our trade effluent customers? Infiltration, very difficult to define. And actually, if you look at PG, you roughly know your population by counting the number of houses. But then again, if there are any void houses, you don't know. And then G, which is the per capita consumption, we can take from our clean water colleagues, times it by 90%. But then in some areas, that's a bit of a misnomer as well, because a study done by the WRC, I think about 10 or 15 years ago, basically found that the GE contribution from per capita per day could be anywhere, depending on social, cultural, and geographical issues, could be anywhere from 70% to over 100%. I think probably by measurement error. So again, all of the elements you can have difficulties with as an engineer, as a flow compliance manager, as somebody who looks at flow. So there is a lot subject to interpretation. Here we go, DWF equals PG plus I plus E. As I said, it's not easy to separate everything out. But at the end of the day, it's a volumetric amount that we can compare to the environmental permit, the DWF consent, and see whether a works is compliant with its DWF consent. Why a works is non-compliant can be another thing. When I was doing investigations when I was at Anglian Water, it was very much around, okay, is it meter error? So yes, all our meters are checked by MCerts inspectors who do an absolutely fantastic job in telling us the uncertainty of a measurement structure. But again, it's every 5 years. Yes, there's the maintenance. But yes, instruments do drift. Yes, they're calibrated. But sometimes, yes, you could get a bit of meter error. Is it population growth? Is it infiltration? Is it a combination of pretty much everything? And that can be a real struggle, finding out what the root cause of any compliance problem is. And I know it's an issue that pretty much everyone has in the industry. So, flow to full treatment, and here we have a picture of quite a nice storm split. It's actually a regulatory figure, and I remember on the flow TAF group there was a lot of arguments over what was flow to full treatment, what was pass forward flow, but I think a safe way to define it is it's a regulatory figure. It's in the environmental permit. It's an instantaneous flow, but it's the minimum works that a treatment works must treat before going to storm. However, something that a lot of people still don't understand to this day is you're only allowed to go to storm in an actual rainstorm or in snowmelt conditions. And it's something that's tricky as part of the environmental permit that I think operationally there is some struggle out there at wastewater treatment works. Even for designers, I remember when I was designing wastewater treatment works, it was a case of, yes, FFT was something to design too. And maybe that's, with everything that's coming up in the next 5 or 10 years, it's something that we're going to have to change. Are we going to have to do more flow and load surveys or longer flow and load surveys? Or are we going to have to do more UPM modelling to define a treatment works or a system, the wastewater system's performance in wet weather conditions? But again, it's always been defined as 3 times DWF. The FFT to DWF ratio is something that's come into quite a lot of discussion in the past couple of years or so. But it has been defined as 3PG plus I plus 3E. So even then, it's not a true 3 times DWF. But of course, you can't get 3 times the infiltration in wet weather. Basic picture of what that looks like, if no one knows what that looks like. But basically, works comes in. On a large works, you quite often have a Formula A overflow. You have that storm split within the preliminary treatment. The flow that passes forward to treatment is the pass forward flow. The stuff going to the storm tank is of course storm flows, and it should be returned if the storm tank doesn't reach capacity, in which case it will overflow. It should be returned as soon as reasonably practical, and again there's a bit of a debate over what is reasonably practical, but that's not something I'm going to cover today. The FFT to DWF ratio, and this comes into partly all the work around DWF that's been done and the shift in the FFT to DWF ratio. Literally, FFT divided by dry weather flow. Historically, it has been 3 DWF. And if you look into a lot of the environmental permits or the old discharge consent, you will see that ratio quite clearly. This comes into the history of the regulation. That ratio was cut into quite a bit in the past 10 years, and that's caused problems with the FFT compliance. As engineers design to FFT for what a works will cope with in terms of storm flows, then you could get positions where works are spilling to storm in dry conditions. This is quite literally FFT non-compliance, and is the point of a lot of the work that's going on in the next asset management period. But when you look at it, truly, the FFT to DWF ratio is a reflection of the type of works that we have. So a relatively small works with very small catchment, very steep hills with a lot of urban areas will need an FFT to DWF ratio which is much higher. A large shallow catchment with large rural areas where the rainfall gets absorbed into the catchment quite a bit is going to be the exact opposite, and it needs an FFT to DWF ratio which is much smaller. And this is important when considering how a treatment works will react to managing flows. And I think probably the point to come here is to look at what the Environment Agency want from water company performance. The Environment Agency's task is very much to get a good ecological status in the river environment. That's not the case over a lot of the UK, and there are some catchments that struggle. Rightly or wrongly, that is the Environment Agency's overall game. We've seen the EDM programme this asset management period. We're seeing the FFT programme. When you bring those programs together, it's very much encouraging the industry to treat as much wastewater as possible through the treatment works. And of course, that's going to cause stress on the treatment works, which will be pushing against their capacity. So let's go into a bit of the history. Regulating flow, probably 1970s, it was 1975 when the dry weather flow definition was come across. Year 2000 was really the start of the MCERT scheme. It's been criticised. I've certainly come across people who have criticised the MCERT scheme as something that was wildly expensive and didn't have the right this or that. But the one thing the MCERT scheme did give the industry was some certainty in the performance of the flow measurement systems. And to be honest, I think the scheme is great. Yes, it is expensive. Yes, to have that certainty in flow measurement data gives the industry a lot more than it pays out in a way. The industry certified, roughly there are 3,500 sites within the MCERT schemes within the water and sewage companies, measuring the dry weather flow performance. And in 2005, when we had certainty over the performance of the data that we were getting, we discovered, really between 2005 2009, we discovered that dry weather flow compliance wasn't as good as we thought it was. So in PR09, the WINET programme looked at dry weather flow. It was the Flow 1 driver, and it changed a lot of consents. The industry, probably between 2007 2009, was basically asked to look at all 3,500 of its sites and say, is that consent appropriate? Now, that's a lot of work to be done in a very short time. What wasn't changed was flow to full treatment. So when I said earlier about the FFT to DWF ratio and the importance of that ratio is eroded. So right there in PR09 and in the following asset management period, when there were a lot of dry weather flow compliance schemes, a problem was set up. So in that AMP5, 2010 to 2015, there were a huge amount of schemes. That FFT to DWF ratio was eroded, and arguably, and it is very arguably, we realised it. The industry realised about it, and I remember the Flow 4 driver coming in to install flow meters at the inlet of wastewater treatment works, included in the WINET programme for AMP6. However, crucially, not included under the MCERT's programme. A lot of water companies who did put Flow 4 flow meters in were sort of penalised for this, because at the end of the day, installing a flow meter at the inlets of a works can be very complicated, especially when there's no space. But the water companies that had those drivers delivered them. They delivered those, they delivered the EDM programme. They did a great job. But I think it was the start of the programme. But that whole FFT to DWF ratio was never really addressed. And it was only in PR19 that the agency, through the WINET programme and the water companies, have had the opportunity to really look at the works and look at flow management. And in the next AMP, AMP7, there's a huge amount of investment around FFT, around really, when we look at it, flow management, in preparation for the last time I heard 2026, flow becoming a regulated parameter with the same weight as the sanitary parameters. The crucial thing is the assessment starts in 2021, and there's a 3 and 5 year assessment period. But of course, 2021, well, that's only next year. So the industry has little or no time to react. And it's interesting to see that. But when you look at this as a whole, you can see that actually the MCERT's programme, the start of the MCERT's programme, kicked off an issue that we're only really starting to fully address in its entirety from a systems-based approach now. And it's taken probably 20 years to get to this point. Measuring and controlling flow. MCERT schemes, depending upon the water company, the vast majority of flow measurement is at the final effluent point of the wastewater treatment works. Now that is very dependent upon the water company. Some have both, some are mainly front-ended, and some are 60–70% back-ended. It was the MCERT scheme, certainly when I was first involved with it, was the self-monitoring of effluent flow. So even psychologically, that pushed you towards a final effluent monitor. It brought standards to within the industry to make sure that we get that flow measurement right. Open channel, closed pipe, electromagnetic flow meters, time of flight meters, open channel meters, either submerged, level-based flow, area velocity, non-contact area velocity. There's a wealth of technologies out. I remember a scheme that I did, that I was involved with about 4 or 5 years ago, but before non-contact area velocity. And we ended up using a partial flow magmeter. It was the only choice that we had. Now, of course, with new technology, I didn't install non-contact AV. The price of that scheme a few years ago was £135,000. Now I could probably do the same job for 15 to 20, maybe £25,000. Really, the development of flow measurement technology, it's moved on quite a lot in the past, even 5–10 years. There was a shift though, as I said earlier, in the regulation section in AMP5 with the Flow 4 driver, and now with the UMON 4 driver, to go towards flow-to-full treatment monitoring. And in some ways, this restricts the technologies that you can use. You're not going to use, even on a small works, a V-notch weir on the inlet of works. Obviously so. Electromagnetic flow meters are great, but again, the problem that they have is they are subject to fouling. Penstock control needs to be used. There was an article recently talking about the use of flumes. And in an ideal situation, yes, you would. Because in a flume, you've got not just a flow measurement device, but a flow control device as well. But it does need quite a lot of space. The argument in the article recently was area velocity is a good, but yes, there's been a lot of debate over it. We've had Bulletin 27 talking about 25 measurement distances. And there's some people still have a lot of question marks over it. But in a works where you don't necessarily have the space, then yes, it is a valid technological choice. In an ideal world, yes, we'd put flumes in everywhere. But that's not possible. Some sites you just don't have the hydraulic capacity within the hydraulic profile. It just doesn't happen. Are you really going to spend £1, £2, £3 million rebuilding an inlet works where you can put an area velocity device in? And the answer is, of course, no. But there has got to be care taken. You've got to make sure that it's installed correctly. The MCERT's inspector, of course, is going to go along. But even in my time, I've seen some very dubious installations. If you're going to use this for A, MCERTs, okay, B, regulatory drivers, C, compliance, and D, anything else, you can see some examples here. The electromagnetic flow meter down the bottom, which is downstream of a balance tank, right next to a valve. The poor installation of flow measurement device is not only going to give you bad data, but it may also give you bad control as well. There's potential for increased maintenance. We've all seen the impact of ferric sulfate dosing ahead of a flow meter and what that can do to both the flow meter and pipe work. I've certainly seen situations where penstocks have been situated far too close to storm weirs, and what happens is the flow channels all the way down the channel, hits the penstock, bounces off, and goes straight down the storm discharge. The ironic thing about that is a metre or two downstream of that penstock, there's a perfectly good working flume, which is absolutely perfect control device. And yes, you may need a bit of change in the height of the storm weir to make sure you control properly. But guess what? It can be a great thing. But again, we have to make sure that installation is correct. You don't want to put a control device right next to the storm weir. You want to make sure everything is working correctly. So there's some things around measuring and controlling flows that even 20 years into, almost 20 years into the MCerts program, we as an industry still aren't necessarily getting right. But moving forwards, I mentioned earlier the massive amount of work that we've got in the next asset management period. When I say we, I'm no longer part of a water company, but it's something I'm certainly hoping to get actively involved in, because there's a huge amount of work for the whole industry to deliver. And it's going to take all of the supply chain plus more probably to deliver it. For those of you who aren't aware, the program of works coming up can be split into monitoring drivers, improvement drivers, and an investigation driver. Why? And the key thing is that point that a works can fail based on flow come 2026. Now, I think my rough calculation of the amount that's got to be spent is around 1.5 to 2 billion across the industry. That's an awful lot of investment. So 5 drivers, and I'll go through each one in turn. First is UMON 3, and that's measuring when something passes over the storm weir and passes over the storm tank. Flow to and from storm measurement. UMON 4, flow to full treatment. UINF 2, an investigation driver based around, well, if I can't use a front end flow meter, can I use the final effluent meter and imply? UINF 5 and 6, which I won't touch on much, but I will touch on. UINF 5, improving that FFT to DWF ratio. UINF 6, improving storm tank size. So if I quickly go into UMON 3, the U drivers are part of the Urban Wastewater Treatment Directive, and the monitoring drivers are basically there to give us knowledge of what's going on. We don't man our works in the UK all the time, so when people aren't there, then we've got to have monitors to discover what's going on. UMON 3, specifically, as I said, to monitor when we're passing to the storm tank and if and when we are passing out of the storm tank in a particular heavy rainstorm. Very simple device, and it should be a simple device that's basically acting as a digital switch. But again, depending upon the technology available, is it going to work on level? Is it going to be, as pictured, a capacitance probe, a conductivity probe? These sort of things is where the problem lies. Moving forward, how are we going to measure them? At the minute, we have no standard. We have no certified products. We have no good practice guide, although one is in development. There's been talk about 2-minute monitoring needed, as in line with EDM1 driver. There's talk about the device being certified, but a lot of these devices are already installed. So how do you deal with that? And equally, where you have a simple weir, it's easy to install, but as you can see in the pictures, simple weirs don't necessarily exist. In the top picture there, you have a nice, very large, curved storm weir. As I said earlier, you've then got a penstock immediately downstream the storm weir. In the picture in the middle, you have the overflow from a balance tank. How on earth do you monitor that? And in the bottom picture, it's of a very small works where the storm weir is actually set within the primary settlement tank. When I say a small works, it really is a very, very small works. UMON 4, flow to full treatment driver. What's expected here is that we measure the flow, the pass forward flow, virtually immediately downstream of the storm split. Fine where you've got it already installed, but there are some works that are so small that you won't necessarily be able to. And again, all of these flow meters are going to be under MCerts. Quite a few of them are going to be retrofitted into the works. The thought is that they're going to need to record every 15 minutes. But again, will it be something more often? There's talk that, yes, it might need to be more often. The industry standard is 15 minutes. But what happens if it is needed more often than we thought? The challenges, again, as you can see in the photo, the lack of space. The top photo there is of a flow control device on a very, very small works. What you can't see in that photo is the storm weirs either side. And you've got less than something like 200 mil on that particular site to put a flow meter in. Practically what that's going to mean, it's something that no flow measurement structure could be installed there on that particular works. Practically, that means you're going to have to take down the whole front end of a wastewater treatment works. Now, it may look very small, it may look rudimentary, but guess what? That top flow measurement device is designed to Formula A. So I can, with a process engineering hat on, I can very confidently say that that works will always pass forward FFT. It will always comply. So to install a flow measurement device in that particular works, in some ways is nonsensical, but it's going to come with a very large bill. And that's, of course, where the UINF2 driver comes in. But for UMON 4, you've got three basic options: flumes, area velocity, electromagnetic. And they all come with advantages and disadvantages. Flumes can be difficult and expensive to install. Is there the hydraulic head? Needs lots of space. It's got very simple maintenance. And it's a great flow control structure. Opposite to that, area velocity, very easy to install, very simple maintenance. But is there a fully developed profile? There's lots of debate about it. Electromagnetic flow meters, depending upon your site, can be difficult to install. And again, when I say that, time of flight, which would be much easier to install. But again, maintenance can be a challenge. Is there an air problem? Is there another problem? So all of the different options we've got have different advantages and different disadvantages. So as a result, this UINF2 driver came into force, and it's basically an investigation driver saying, can we use the final effluent flow meter? Resulted in that an investigation driver being raised. There's about 1,000 sites within UINF2 across the industry. Got to be delivered in the first 2 years, but it's going to require very detailed, very specialist surveys, not just on the flow measurement structure, but it's going to involve temporal hydrodynamics and not modelling the works, but it's going to involve a lot of specialist knowledge, which arguably the industry outside of the MCETS inspectors have great skill in this area. But again, the detailed process knowledge isn't what they're expected to do on a normal day-to-day basis. So really, I think to deliver that in the first 2 years, it has to be done. I'm not sure anyone really knows how at the minute. And if we don't, there's a lot of expensive investment that's due in the first year of AMP8. And again, to deliver 1,000 installations in the first year of AMP8 isn't going to be possible. Once we've got all the data, once we've got all the monitoring done, actually, how do we interpret that data? The FFT and storm flows have to be matched together. We've got to see exactly what's happening, understand what's happening. Some people will say, oh, use artificial intelligence. It's a buzzword at the minute. Not going to happen. There are some automated systems out there, but again, they need that interpretation. They need somebody to look at that data. Is the site in wet weather conditions when it was going to storm, for example? Was it raining? Both the pictured sites there, the answer was, of course, no. One was both were bouncing penstocks. Was it treating flow to full treatment with an uncertainty measurement? All of it needs to be managed, mapped, and understood. And there's a lot of work to be done there. And systems that are probably being developed now or in the past few years to be done. So again, the challenge that's being faced, it's arguable that we don't know what that challenge is fully within the industry at the moment. To touch on the improvement drivers, yes, they're there, they exist, large investment in there, mainly going to be developed by the capital partners, but it's around increasing that capacity through the treatment works, making sure that even in the future that those works are treating what they should be treating, and that we're not having FFT non-compliant sites. The UIMP6 driver, quite simply, 2 hours storage or 68 litres per person per day. Numbers of schemes out there, relatively small in the grand scheme of things, but those schemes are relatively large in capital investment. When you put a storm tank in, putting yet another tank in, putting all the control systems around that tank, it is quite costly. But the challenge is moving forward. The technical delivery of the WINET programme, it's something you can quite frankly ask, is the water industry really set up to deliver it at the moment? There's a limited skills base in flow monitoring. The people out there who do it are really good at doing it, but they are specialist knowledge. People who can look at process knowledge and look at the flow measurement structures, again, it's a unique skill in the industry, and really we're lacking in that skill. We've got a relatively small number of technical experts who can do it out there. But the cost of ongoing asset management managing an MCERT's asset base, when I used to work with it, I roughly calculated I was spending about £1,400 per instrument per year. And I was at that, the asset base was gradually getting better. It felt the right level of asset management. Arguably, it's not asset management, it's instrumentation management. But that sort of investment needs to be there. Now, if you've got a company spending 1,400 quid per instrument at the moment, what's that going to be in the future? Are we going to still keep those FE monitoring sites? Actually, if they're there, they've been invested in, it's a shame to lose them, but yes, there's a cost of maintaining them. The physical data management and accounting, and it really is operation. There's going to be a cultural change. Certainly, operations have a need to use a storm tank at time for on-site work. Yes, there's a procedure for that, going to the Environment Agency and agreeing a way of working. But the flow compliance managers in the future, the flow managers or the regulation departments in the future are going to have to explain every single time a site goes to that storm tank. Every single time. Now that's potentially a huge and vast amount of work. How are we going to do that? How are we going to manage that amount of work? And it's a big challenge moving forward. There's some technical issues. I spoke about Bulletin 27, and there you go earlier, talking about large measurement distances. I think in the end with Bulletin 27 we got to the right point and agreed, have we got a fully developed flow profile? There's going to be some more work on this, and some of the water companies are leading on that work, which is great. And we'll get to the bottom of area velocity, and it's a great piece of work. But what's next? The certification of storm duration monitors and the standards they're going to have to conform to. Are we going to get anyone in the supply chain wanting to have a storm duration monitor? Putting an instrument through MCERTs is a very costly process. Is there a right price point for the industry and for the suppliers to put that device through? The installation of storm duration monitors on technically difficult applications, as I showed you earlier, that could be just an overflow in a tank. Well, how exactly do you install that monitor to get it right? The assessment rules. We've got a strong minimum standard for MCERTs, but it's all centered around dry weather flow. There's not really that depth in the documentation at the moment around how an MCERTs inspector is expected to assess that system. And again, the management system. How do we bring flow-to-full treatment into the management system requirements? And what does that look like in the future? So there's a lot of questions, and of course questions bring about risk. And it's quite a lot of risk that the industry is expected to manage at the minute. There's a lot of unanswered questions that we're going to have to answer pretty quickly. So at that, it's a whistle-stop tour. I could literally go on for quite a long time about this, but it's asked quite a lot of questions. It's given a bit of history about where the industry's come from, where it's going to. Now it's kind of over to yourselves and really the industry as to where we think things are going. So, are there any questions from anybody? If you just pop it into the chat window, we can go as we come along. And again, if anyone's got answer the questions, then please do holler up through the chat window. It is being recorded though, so Mark, you are typing away. No pressure, Mark. So as Mark's typing, does anyone else have any questions? Can you just run through those two catchment examples again in relation to FFT to DWF ratios? I did go through that quite quickly, and it's a theoretical situation where you have a very steep catchment in an urban environment, so say concrete, where the water is going to run straight off and go into the sewer. It's going to hit the sewer very quickly, and it's all going to hit the sewer in a relatively short time. So imagine a very steep valley, which is all concrete lined. It's all going to get to the bottom of that valley at the same time. It's all going to run into the sewer at the same time. It's all going to hit the wastewater treatment works at the same time. That way you're getting a very short burst of flow hitting the works. You can argue, okay, it's in a storm, but again, even in a storm, even in a light storm, the flows are all going to hit down into that works at the same time, which means the FFT to DWF ratio wouldn't necessarily need to be 3, it could be 4, 5 or 6. Where if you've got a very flat catchment where the velocity of the water is relatively slow, you've say got peat, which is a great water absorber, then that flow is going to take a lot longer to reach the wastewater treatment works, which is again where you can have an FFT to DWF ratio that's much, much smaller. Again, it depends upon the size of the works, so you'll find a very large coastal works, for example. If I use the example of Ringsend in Dublin, Ringsend in Dublin has an FFT to DWF ratio which is barely over 1, because it's a very large works and very complex catchment. But it's all about how quickly a flow will hit the works. And if it's going to hit the works all at the same time, then of course the FFT to DWF ratio needs to be much higher.